Hi everyone, welcome to day 4 of my cloud computing series. So today we will going to learn these topics. First, critical session problem. Second, conditional variables and semaphores. Third, producer consumer problem. Fourth, reader rider problem. And fifth, the dining philosopher problem. So we are going to discuss these five topics. So where is my notes? Okay. So if you see when you writing something like this code count plus plus, so what exactly happened? This count plus plus storing in a temp this count plus plus this will happen. So it take one variable temp. So if you see there is a Aadhaar card database and this four centers A, B, C, D, and this same times doing count plus plus, like they are updating something. So in this what will happen, if you see count is 11 and A also doing some updation and B also doing some updation. So in this what will happen, count plus plus is equals to storing in a temp 11 plus 1, so it will be 12. But this is not safe because of it is time. In the meantime it all parallelly B is running, so it also like 11 plus 1 so is equals to 12, but there is has to be 12 but it is 11. So this is the problem, and this problem is called race condition. This happening on the race condition. So what will we are going to do, uh, we for solution of the race condition, there is we can do atomic, like there is a in C++ atomic variable you can do temp like that variable, so it will be doing that. Or you can do mutual exclusion. What will happen if T1 has come to this critical session, this critical session, this other database is a critical session, let's suppose. So thread 1 go this, and if thread 1 has go in this critical section, then T2 has to wait. Okay, so these logs can solve this problem. And third is semaphores has two types, one is binary and third is count. In binary it takes 0 or 1 value, and in count it's depend on the instance value. So semaphores, like you can use flags also in that. Okay, bound waiting, if you see this happening in a bound waiting, if you see infinite waiting will be happen in single flag. That's why you can use second two flag, like Peterson solution. So what will happen in Peterson solution, you can use two flags, like if like this is the example T1 while 1, then flag 1, then you can see this example. In this you can understand that if T1 has gone, then T2 has to wait. If T2 has gone in critical session, then T1 has to wait. This like this. But Peterson solution is only safe for through two threads, not more than that. That's why logs disadvantages, like contingation means it will be like the deadlock will be happen. So, like contingation means like T1 has come in this, so is T1 is like doing something and death, so it will be indefinite waiting for T2 and T3. That's why condition will happen, the disadvantage of logs. And the second is if P1 and P2 is there, and P1 has take these resources, and P2 and P1 has want this R1 resources also, but P2 has acquired this R1. So if you see, P2 also need R2, and P1 also need like P1 need R1 and R2, and in that same P2 also need R1 and R2, but P1 has take R2 and P2 has take R1. So in that you can see there is a indefinite log, because it take they are not releasing the P2 not releasing P1 not releasing R2, and P2 not releasing R1, and both need R1 R2. So in that case this will deadlock will happen. and debugging issue is put a headache in this also, and starvation will be happen. And so for this the conditional variable come the picture. What will happen, it conditional will like wait and signal like lock give the signal. If you see, thread 1 has come to this critical session, but T1 something doing work. So what will happen when T2 has entered this? So when T1 will go this, it's check, and it will checking if there is T1 is working something. If there is a condition like T1 T0 like that, T2 is doing something, then T2 has complete their work, and it gives signal to T1. Then the T1 can go to the critical session CS. Okay, now you can understand. So semaphore is nothing but an integer. Okay, so resources single multiple instances, like I have explained you, like the semaphores has binary and counting means like two or more instances like that. Okay, so this is the example you can learn from this. You can check this example, see this example, you will understand that. Okay, now we will dive into producer and consumer problem. It's also called bounded buffer problem. What will happen, producer thread doing something, pro- uh, like post something, and consumer consume that thing. Okay, so what will happen when producer doing produce something, then consumer not consume that thing like that, and consumer has to uh, if a producer doing some posting, then consumer has to wait. When consumer has done, then consumer can like that. If the problem is that if you see, uh, producer must not insert data when the buffer is full. The problem is consumer with the buffer is full, then producer not full that, and the consumer must not pick remove data when the buffer is empty. When buffer is empty, then consumer can't take any like that. So this problem is there. So what will happen, solution of this is semaphores. So doing semaphores, you can take the solution from this book. Now we jump to the fourth topic of our read and write problem. So what will happen, you read thread something and write thread. So what will happen, if in a database some writer is doing something, then read cannot interfere, and the writer to cannot interfere. Because if a writer are doing something like ABC, and you are reading at the same time, but after 2 minutes writer also to updating something, so you can read invalid data. So that's why when writer doing something, then writer 2 and reader 1 and reader 2 cannot enter that critical session. So by for this problem, what we'll going to do, like if you see, if one or more reader are reading, no issue. But if one reader or one writer and some other threads parallel, raise condition data inconsistency will happening. So for this problem, what we're going to do, we will doing same by using semaphores. You can use binary or counting as what you want. So you can see this solution, you can understand. Now we will going to understand dining philosopher problem, our last topic. What is dining philosopher problem? There is a philosopher sitting in a dining table, and there is a noodles, and there is a five forks each. So if philosopher only think or only eating, so when philosopher want to eat, but they all take one fork, so then they have to wait, and this situation make deadlock. So for avoid for deadlock, what we are going to do, semaphores also we are going to do. But then also there will be a deadlock situation will happen. So what will we going to do, we will going to avoid deadlock by using this three step. allow at most four philosopher to be sitting simultaneously. You can only sit one philosopher or four philosopher at the time. So what will happen, this philosopher take this, and this like this philosopher take this and take this fork and take this fork and take this fork like this. So this philosopher has that, like this philosopher take this fork, this philosopher take this fork, this philosopher take this fork, this philosopher take this fork. So the five philosopher has not sitting, so now philosopher one can take this fork. So in that they can do their work, and after that they release this force to two force. So what will happen to force philosopher to can take this fork also. So in this we can avoid deadlock. But the main problem is we have to sit only four philosopher at same time. And second, we can avoid deadlock by using allow one philosopher to pick up his fork only if both fork are available, and do this he must pick them in a critical session. If you see this like problem, like we can like create here only like critical session here, like semaphores, like if this person has, so this have to do, like we can do that condition. And we can do odd even rule. What odd even rule? This is this odd even, like this and this are odd, and these are even. So what will happen, only odd even rule, what will happen, like if you see an odd picks first his left fork, like for left fork. So what will happen, left fork, and he has to took right fork, and he has to pick left fork, and he has to pick left fork. So left fork like that. So what will it going to, and like whereas an even philosopher pick his right fork, then his left fork. So what will happen, you can avoid deadlock. So these three solution we can avoid deadlock. So I hope I have explained you very well. And Mike, so I'm not going to like explain in detail, because I'm going to explain over through like what I have learned from this concept and all. You can see my notes and you can understand by this. So my basically point of view is like I have to create short videos, that's why I'm not explaining in details. So this video is in short. So I hope I explain you well. Now till that time we can meet tomorrow, and with new concept. Thank you everyone. Bye.